All right, gang, this is number 12. Number 12. So let me read it. So a zookeeper reordered the feeding schedule for a baby rhinoceros for 20 weeks. The table and the scatter plot show the percentage of the baby rhinoceros's body mass, and that was used to determine the amount of food given for each feeding as a linear function. Now, key thing is, right here it says that it is a linear function. So that means when I have this table, I need to be doing linear things to it. Well, anytime I get a table, I'm probably going to just put it into my calculator and see what I can find out. It says determine the amount of food given for each feeding as a linear function. Well, let's take this and let's put this into my calculator. So I'm going to take a second and I'm going to put this into my calculator. I'm going to go to Stat, Edit, and I need to put all of this in. Now, I don't have all the table on here, but you do on your paper. So I'm going to pause this. I'm going to go back over here and I'm going to put this in, but I don't want to waste your time while you guys put it in. And boom, we have it all in there. Okay, so now I have my table in here. So remember, we're going to go to Stat, Edit, and we're going to go to Calculate. Now, it told me that it wanted to know a linear function, so I look at linear. I'm going to go down to number 4 and I'm going to hit Enter. And remember, you can hit Enter all the way through, but I do want to store it. So remember, you can do alpha y equals, and it gives you these up here. Go to the y vars, and you can store it in y1. All right, calculate. So it's going to give me my equation. Now, I don't really have to save that equation because my calculator already did. But remember, the question was, let me go back so I can read it. What is the best prediction of the percentage of rhinoceros's body mass that would be used to determine the amount of food given for each feeding when it's 25 weeks old? Remember, these were my weeks at 1 week, 2 weeks, 4 weeks, and we saw that it's going down. So when I look at this, one of the interesting things I want to look at is logically what makes sense on this. So as I look and I see I've got 8.5%, I've got 6%, 2.5%, and 10%. Well, when I look at this, 25 is going to be way out here, right? This is going down pretty quick. I'm probably safe to say it's not going to be one of those two because they're just too big. So I'm thinking one of these two. So even if I couldn't figure it out logically, I could narrow it down to a 50-50 chance. But what I'm going to do, let me zoom in on this a little bit so you can see a little better. I'm going to go y equals, and I've stored that in there. Oh, let me get this one out of the way. Okay, it's stored my equation. I'm going to go to the table, and I need to look at 25 weeks. Now, here's the interesting thing. If I look at my table, 1 is 19.24. It's a little bit off, isn't it? 2 is 19.5, and I've got 18. Don't panic over that. When you do regressions, they don't always match. So remember, I can do second table set. You could also hold it down. Hold on, I went over there. Second table set. I can change that to 25 and then go back to my table and it'll take me there. You could hold your button down to get there. 6.3833. Which one's it going to be? Yep, right there. All right, watch that again if you need to. That's a really good one.